So we had talked of vectors, and I had gave you examples of vectors, type of vector, angle between vectors. But my question to you is this: say for example, there are some quantities which have direction. This is a question, like current. Current has direction, huh? We say current flows in this direction, then current goes in this direction. Then pressure is also there. Pressure, it exert a pressure downwards of 10 pascal. Say for example, it exert a pressure of 20 pascal upwards. So in that case, but if I say, in case of the current, whether it's a scalar quantity or a vector quantity, current is a vector quantity, it has direction. Pressure has a direction. So pressure is a scalar quantity or vector quantity. So for example, this is the roof. So this is the pressure, 10 pascal downwards, 20 pascal upwards. So what would you say? These are the scalar quantity or the vector quantities? These both are neither scalar nor vectors. We call these quantities as tensor quantities. Tensors quantities. So tensors, these quantities are tensor, though they have direction, but still they are not vector because they don't follow vector law addition. I'll tell you this. Just for vector, for a quantity to be vector quantity, there is a second most important point is they follow vector law of algebra. Vector law of algebra. Okay, relax, I'll tell you. Say for example, I said there is one current and there is one current. Okay, 5 ampere, they are coming and at an angle of 60 degree. So the thing is, this resultant current would be of what ampere? 10 ampere, na? It doesn't depend whether what is the angle, what is that. Say for example, this is one wire and this wire. So 5 ampere coming here, 5 ampere coming here, and they're going through theirs. So it's not like this point becomes of 0 ampere. No, they merge and become 10 ampere. So just like they're adding just like scalar quantities, they're not adding like vector quantities. Okay, vector quantities are not like that. If they have, if it is a vector quantity, so in that case that was 0. If it is a vector quantity, so in that case it would be not be 10, something different. And what is that different? We would learn it with some laws to add vector. So the next topic is vector addition. But from this point, actually I took this point at this moment. There is a reason. First reason is you need to have one more point regarding the vector, that they follow vector law of addition. And how does the vector edit? Second more important point comes to your mind. What comes to your mind? The second point which would comes to your mind, how they are added. So now the second important topic is vector addition. Okay, so there are two methods for that. One is a graphical one, and another is an analytical one. So first we'll cover the graphical one. Okay, let's talk about the graphical method to add a vector. Graphical method to add vectors, and here I would cover 3 points: Strangle Law vector addition, Strangle Law, second is parallelogram law, okay, I'm writing in short. And third is polygon law of vector addition. Polygon law. So without wasting our time, let's come to the first law, which is triangle law. Okay, so triangle law. Triangle law. Now let's come to the point. See if there are two vectors and you need to add those vectors. So how do we add? If this is one vector and the another vector, so we need to match with the triangle law. I'm telling you, we need to match the tail of the other vector with the head of the first vector. So this is the second vector, B vector. Okay, the tail goes to the head of the A. Okay, so if the two vectors are arranged like this, then the resultant of them would be represented by, I represent it by red color, would be represented by another vector but in the opposite pattern. See, the pattern is moving like this. You are moving like this, this, okay, tail to head, then the resultant, the same pattern would be tail to head. This would be the same pattern, but the resultant would be represented by opposite of that. That means it would be like this, not covering the loop. So opposite pattern, it would be represented by opposite pattern joining the head of one and tail of one. The resultant of A and B, resultant, we call this as resultant. I am going to use the letter R and the word as resultant. Resultant will be represented by R, and which touch the head of B to the tail of A. No, opposite of that. Whatever I said, the opposite of that. That's why I've said, because you can recollect it 2 more times. Which would touch the tail of A. So loop is like this now. So it will go against the loop, tail of A and head of B. So just remember, it would goes against the pattern. So pattern is like this is the pattern, so it would go against that, so it would be the resultant. Okay, so that is vector law of triangle law of vector addition. We'll do some problems with that, don't worry. And it is a very good law, and it helps you to get a it is very useful for the time being. For the initial stages, it is very, very, very useful. Okay, say for example, there's a girl name is Anjali goes 3 meters in the east direction, then suddenly moves to her right and walks 4 meters in the north direction. So what is her displacement from the initial position? If I ask, tell me her displacement from initial position. If I ask this thing, so this is one vector, this is another vector. So displacement in initial position, final position, the resultant. So resultant would be represented by, this would be the displacement now. Okay, here is the R vector is the displacement resultant of 3 and 4. It is just the resultant of 3 and 4. Can you see that the two vectors? It is again the triangle law. Doesn't it look like this is one vector, this is one vector, so resultant of this would be this, and this is the resultant vector. Actually this is the resultant of 3 and 4. And how would we know the resultant of this is a triangle? It is a triangle. So which one side is right angle triangle? 3 and 4. The other side would be 5. So the resultant would be 5 meters, and we can easily find the angle as well. If I'll ask if it's a vector, somebody ask the angle as well. This is just a triangle. Are you getting what I'm trying to say? This is just a triangle, right angle triangle, 3 4 5 triplet. Okay, I'll give you another information which is very important. If this is a right angle triangle and a very basic triplet 3 4 5 3 4 5, so angle opposite to 5 is 90, angle opposite to 3 would be smallest, and angle opposite to 4 would be greater than 3. So angle opposite to 3 would be smallest, and it is 37. This is standard, you need to remember this. And angle opposite to 4 is then, second largest, which is 53. So if I ask sine 37, so sine 37 perpendicular over hypotenuse, so perpendicular in that case would become 3, hypotenuse would become 5. Cos 37, in that case base would become 4, hypotenuse become 5. Sine 53, perpendicular over hypotenuse, perpendicular would be 4 and hypotenuse would be 5. Cos 53, base would be 3 by 5. This is the case. Okay, and so you go with the 10 as well. Are you getting it? So this is, you need to remember, because in physics we are going to use it a lot, hell lot. Okay, so let's move ahead. So I'll give you another example with that. Okay, and what is that? Say for example, say for example, a person is moving with a speed of 10 eastward, and then suddenly he took a 90-degree shift and goes 10 with the speed of the 10 northward. So find acceleration in, say for example, 5 seconds and 5 seconds. So acceleration, you must all have known, acceleration is rate of change of velocity with time. Okay, rate of change of velocity. So first velocity is this v1, second is v2. So acceleration is v2 minus v1 over time. Now here the question arises is that of subtraction, minus. So if I talk of minus, subtraction of vector, it is actually addition of vector, though we'll do separate question over that. But if I talk of subtraction of two vectors, a minus b, so it is actually a plus negative of b vector. And what is negative of a vector? Just the opposite of that vector, that's with opposite direction, same vector. If I say this is vector b, so what would be the negative of vector b? Of course this would be negative of b, same magnitude but opposite direction, east west, north becomes south, just that. So let's talk of the problem. v2 is this, v1 is this. So if I say v2 minus v1, so that is v2 that is 10 minus v1 would become this. Okay, so what would be the acceleration? Then we'll do it by the triangle law of vector addition. v2 is this, okay, v1 would be this, okay, v2 is this, v1 is this. So what would be the resultant of them? Up now is the addition. Okay, this is negative of v1 na? So now just we need to do the addition. You can say that it is v3 or anything else. Okay, so v2 plus v3, you just need to add these two vector, v2 and v3. And how we learn? Head of one, tail of one, then the resultant would be represented by, I'm representing it with a different color. goes from the head, goes from the tip